The other topic that we need is resultant velocity. Velocity is relative. Resultant velocity has to do with a moving object in a moving environment. Examples that you will be faced with is a plane, aeroplane moving in air. The air is also moving. An example again I can give is maybe a boat or a ship in water, moving in water. Okay. Such examples. So what you need to know is the environment is moving, the object is also trying to move. Then they ask you, what is the resultant velocity? Alright, let's look at this example. We have a stream. I've been given this. This is water. Then you have a boat. Let's create a bigger boat. This is a boat. If the water was not moving, this boat can move at 5 meters per second, but the water is also moving at 2 meters per second. Then they ask us what would be the resultant velocity of the boat, obviously, in magnitude and direction. Remember, velocity is a vector. That is why we are not just saying 5 meters per second, we are also giving the arrow or the direction. 2 meters per second, you give the arrow in that direction. What would be the resultant of that example? 5 or 7? 3. In which direction? Okay, simple enough. The book I'm reading, this guy is talking about planes. He says, if this was an aeroplane, it would be hard for this plane to fly if the air is blowing against it. If the water changes direction, the water is flowing in that direction, the resultant will not be 3. The resultant will be how much? 7 meters per second, because the water is flowing in the same direction. Okay? So now you put up some points, same direction. If they are moving in the same direction, how did we get this 7? We added 2 plus. Okay, opposite. Let's subtract from minus. Basically, the velocity of the environment can either help you move or it can slow you down. If it's moving in the opposite direction, it will slow down the boat. If it's moving in the same direction, it will help you move. It is pushing you forward. Simple enough. Keep this in mind. Our questions are not going to be like that. Our questions will be something like this. The boat is trying to go that side. Now I'm just using lines. 5 meters per second. The water is flowing in that direction at 2 meters per second. I've used a lot of lines, but you only need one line, right? The water is flowing in that direction. So if this boat is trying to go like that, the water will push this boat in this direction. Even though the boat will be facing this side, but its movement will be like that, facing this side, because the environment is also moving. Then they ask you, what will be the velocity, the resultant velocity of the boat? What will be the direction where we will find ourselves going? Simple calculations. What you do is everything from the start. This one is going that side, the other one is going that way. This will go somewhere like that. If you want, you say for the water, this is 2, this is 5. The water pushes that side. Where the water finishes, the boat also goes in that direction from the start to your finish. You can calculate for theta, or you can calculate for any of the two angles. If we have this, the resultant horizontal square plus vertical square, 2 square plus 5 square meters per second. Come in. Five from 3 For your direction, we know our direction, right? How to get our direction. When it comes to direction, the same trig ratios we were using, we can use cos, we can use tan, we can use sine. If you use tan, your vertical over your horizontal, 5/2 east, whatever degrees to the north. Now, this is the reason why I do not want to teach relative velocity, then the next thing we are doing resultant velocity, because the calculations are similar. We do Pythagoras, we did Pythagoras, we do trig ratios, we did trig ratios in relative. Now, this is where the difference is. And when you answer such questions, please take note of this. This is the only thing that differentiates the two topics that we did. Resultant velocity, if the environment is moving in the same direction, we add. If it is in the opposite direction, you minus. Then the rest is the same. That's very important. The ship is going south, or is trying to go south at 42 kilometers per hour. This is the ship. There is a current flowing east. Instead degrees north. Yep. You are saying northeast. North, that is 22 degrees north. We have our north, we have our east, we have our west, this is south. If I put my line here, it's east, 22 degrees north. Yeah. Northeast what? North 90 minus 22. 90 minus 22. Northeast is this one. North 22 degrees east. That's wrong. This direction and that direction are the same. What this means is it means your angle starts on this line, the east direction, then you are turning 22 degrees towards which guy? The north. That line which meets here. This line, this direction, it's east 22 degrees north. Now, this direction, north, we are starting on the north direction, right? We turn 68 degrees towards which? East. It's still the same direction. We cannot say north, this guy is not like that. This is something else. This direction is something else. But these two are the same. That was not necessary. Alright, so the current is flowing in this direction, which is the same, the northeast direction, but if you say northeast, you have to say 68 degrees. If you just say northeast, this is equal to 45 degrees. If they just say northeast, they don't put the angle in between. It's 45 degrees. This is northeast. This is southeast. This is southwest. This is northwest. These ones are 45 degrees. If they do not put an angle in between, take 45 degrees. But in this case, we are given an angle. Alright, so what is happening is that at what velocity? 7.2. Before you calculate, make sure the velocities are in the same unit. This one is kilometers per hour, the other one is also kilometers per hour, which is fine. If it is meters per second, make sure both of them are in meters per second. Alright, then the question is calculate the resultant velocity in magnitude and direction. What we have is the current or the water has two components. The water has got two components. This is water. It has got a component going this side and there's a component going towards the north direction. Horizontally, you consider this guy and that guy. Horizontally, this guy is just 7.2. Here we have 32 degrees, which will be cos or sine. Cos 22. This will be 7.2 sine. Okay. Horizontally, I only have 7.2 cos 22. Is the ship going to the left or right? Horizontally means left or right. the ship is not going to the left or right. Okay, so we only have this. You calculate kilometers per hour. You get your answer is 6,675. And it's going which direction? To the east. So this is the velocity that will push this boat. Instead of going south, the boat is trying to go south, the water is moving in that direction. The boat will not go straight southwards. What will happen is that the boat will be facing this side, but its movement, because this guy is pushing that side, its movement will be like that. Somewhere in that direction, somewhere in that direction. And that is what we are trying to find. Because the water drove this off course. The captain of the ship says we are going this side, the water is blowing it. Instead of going that side, they find themselves going the other direction. Alright, then we go to the vertical velocity. Vertically, we have two. Vertically, we have two. The ship can move at 42. Going which side? Downwards. The water is going in the upwards direction at 7.2 sine 22. Right? I take the vertical component of the water, the current. I take the vertical component of the ship. The ship, we already know it's going south. The water is going towards the north. So it's going in that direction. Is this same direction or opposite direction? Opposite direction. What do we do with the opposite direction? Subtract. How much? 8, 9. Okay. For the direction, since I gave this guy a positive direction, our answer is positive. Therefore, this direction is the same direction that we pick. Since I gave the water a negative direction, if I had got a negative answer, that's the direction I would pick for this guy. Okay? Then these two are summarized up with those or reduced to that. What we have the water 6.675 to the east, 39.303 to the south, your start, your end, your resultant, your direction. If this is what you choose to calculate, this will be your direction. This direction will be east. Whatever angle you get is south. East, south. If you calculate for this line. If you choose to say, let me start with the ship, 39,303. This is the water, 6.675. Your start to end. You calculate for this theta, your resultant. it will still be the same size as that. If you calculate for this angle, it will give you south. Whatever number you calculate for, east. This will give you east, south degrees.